Good morning. My name is David Bongo. I'm coming to talk to you today about the atom and its structure. And we will look at the atomic particles and their characteristics, or if you like, their properties. We will also look at the arrangement of electrons in orbitals, and we'll also look at the characteristics of each of those orbitals and what they can take in terms of number of electrons. First, we want to start with defining the atom itself, which is the smallest particle of an element. Sometimes it is defined as the smallest indivisible particle of an element. But if you really look deep into it, we can actually split the atom to get other substances, which is why we are talking about the structure of the atom today. And it is very much important to know that every element is very unique. Each atom is completely different from other atoms of other elements. So in that case, if you look at the periodic table, you see that the arrangement of the elements are all in that sequence. They all have very, very unique properties. I'm going to show you what a typical atom will look like in terms of its structure. We have this one here, which tells you that the atom has, in the middle of the atom, you have what we call the nucleus, and outside you have the electrons, and the electrons are located in the shell, or if you like, you say the orbital. Now, there you see the atoms, the protons are positive and the electrons are negative. I just indicated that right at the top there. I don't know if you can see that. An example of two atoms that I have selected, you have here helium and hydrogen. At the top, which is this one, is representing the atomic mass, and at the bottom is representing the atomic number. So it means in hydrogen we have atomic mass 1 and atomic number 1. And what we cannot see here is the number of neutrons. The neutron is actually calculated. So you would have to subtract this atomic number from the atomic mass. In that case, neutron is not present in hydrogen. So we have 1 electron in hydrogen, 1 proton in hydrogen, and 0 neutrons. But when you come here for helium, the atomic mass is 4 and the atomic number is 2. So if you subtract 2 from 4, you're going to get 2 neutrons for helium, and then you have 2 protons and 2 electrons. So this is a typical example of 2 different atoms. The properties of all the atoms in this hydrogen are completely different from the properties of the atoms in this helium. So it is very, very important to note that. And we are going to individually talk about the electron, the proton, and the neutron. If you look at this one here, I earlier on mentioned that the proton is positive and the electron is negative, and the neutron has no charge. The proton and the neutron are actually found inside the nucleus, and they actually account for the mass of the 99.9% for the mass of the atom itself. And the electron actually has a mass, but it is really, really, really insignificant compared to the mass of the proton and the neutron. So we say the mass of the atom is really determined by what you can get combining the proton and the neutron together. Around the atom, you have orbitals, which are actually arranged according to energy levels. And what the orbital actually represents is the region where you have the highest probability of finding electrons. Here I have drawn energy levels that show different levels of orbitals and the number of orbitals per each energy level. Energy level 1 is represented by, the orbital there is represented by S. Energy level 2 has two kinds of orbitals, the S and P orbitals. Energy level 3 has the S, P, and D orbital, and energy level 4 has S, P, D, and F orbital. Each of these orbitals take a certain number of electrons. For the first energy level, which has the S orbital, it takes a maximum of 2 electrons. The P orbital takes a maximum of 6 electrons, and the D orbital takes a maximum of 10. The F orbital takes a maximum of 14. We will see why we need these numbers very soon. And here, if you see what I have here, the number of energy levels are here on this side. Actually, it's really reflecting in a different way than you will see it. The first energy level, which is represented by S, we said it takes a maximum of 2. And the second energy level, which is represented by S and P, takes a maximum of 8. The S orbital takes 2, and the P orbital will take 6 electrons. So if you add 6 and 2, you get a maximum of 8 for the second energy level. The third orbital will be represented by S, P, and D. And the total number of electrons that go into that level will be 18 electrons. So the first will be 2 plus 6 plus 10, which gives you a total of 18. And the fourth energy level has S, P, D, and F suborbitals, which takes a total of 32 electrons. So this is actually showing you the different orbitals that are present in the energy levels. I'm going to really give an analogy of energy levels and the number of electrons. If we look at these energy levels here, take for example one house that has one room, and in that room you can only put 2 people in that room, and when they lay down, they lay in opposite spins. If you look at these electrons here, you see that one is pointing up, the other one is pointing down. So this is how electrons are arranged in orbitals. So we said P has 3 orbitals, so a house that has 3 rooms can take a maximum of 6 people. And in each room, there's only going to be 2 people in that room. So when they lay down on the bed, one will put the head up, the other one will put the head down. And this is the arrangement. So electrons are arranged in this way simply because if you put the 2 heads together, there's going to be repulsion. And when you come to the third, to the energy level that is, let me see, this is the fourth energy level. You have this number of suborbitals, 5 suborbitals, and each will take 2. That is why we have 10 electrons in the D orbital. And in the F orbitals, it takes a maximum of 7. It has 7 rooms, and if you have a house with 7 rooms and each room takes a maximum of 2 people, so you can have 14 people in that particular house. So if you have 7 orbitals, you can take a maximum of 14 electrons. But there is another way we can actually calculate the number of electrons per each energy level, and I'm going to show you that very soon. If you look at this formula here, 2n squared, the n there represents the energy level. Let's say you have energy level 1. If you have energy level 1, It's so 2 times 1 square will give you only 2 electrons. If you have energy level 2, so 2 squared is 4, and 4 times 2, that gives you 8 electrons. If you have energy level 3, 3 squared is 9, 9 times 2 is 18 electrons. And going back down to the fourth energy level, 4 squared is 16 times 2 is 32. So this is how electrons are arranged in atomic orbitals. We will talk tomorrow about how these electrons in the orbitals actually take part in chemical reactions. Just to give you a heads up, we have what we call ground state and excited state. When atoms are in the excited state, it means they are ready to give up their electrons or to receive their electrons. The group of atoms that give electrons away during chemical reactions, we call them metals. And the group of atoms that receive electrons during chemical reactions, we call them nonmetals. And when these ones receive electrons or give away electrons, they have a different property altogether. An atom that gives away electrons, in the case of metals, they form what we call cations. That means when they well, I'll talk about what cations means later on. And then an atom that receives electrons are called anions. If you have a compound that has a metal and a non-metal, or the positive and the negative part, that compound, when you dissolve it in water, it can give you what we call an electrolyte. And here, the positive ion will be called a cation, which means it will be discharged at the cathode, and the negative ion, which is called the anion, will be discharged at the anode. There's a whole lot of thing about that. Also, we call that electrolysis, and there are calculations that we will do to determine the mass of substances that are discharged at each of those electrodes. So we'll look at that in the next class, and then if you have any questions before that, feel free to send me your questions, and then I'll be more than happy to help with that. Thank you very much, and see you tomorrow. Bye-bye.